Hello everybody, my name is James Ryan, and I am here to teach you guys how and why polynomial division works. Now some of you might be wondering, what is polynomial division? Well, first of all, let me explain what I mean by how and why. You may or may not have already learnt how to do polynomial division in school, but you may be very confused as to why it works. You may have already know why division works. I've put a video up on that already. But you might want to know why polynomial division works. Okay? And that's what this video is for. This video will go through the generalization of regular division in order to derive polynomial division from that. It's a very roundabout kind of method of getting to it, because what I'm basically doing is taking something that I'm very familiar with and trying somehow to morph it into what I found was long division with justifiable reasoning. So it's not the straightest thinking process, because it's like I've got a hidden GPS and I know exactly where to go and I know where all the secret routes are, and you guys are just like, James, why are you going off road? Because this is the way to go. And then when you get there, you'll be like, oh, you're right, James, but it's not the cleanest journey, is what I'm saying, because it might not even be the textbook version, but it's what I figured. Now, for those of you who've sat through that just now, thinking, okay, I actually don't know what polynomial division is, James. Polynomial division is basically the same as regular division, except you are dividing polynomials by each other. Quick example: polynomial. Polynomials basically, well, okay, look it up. You should know what a polynomial is. Basically, something like this is a polynomial, and something like this is not. Okay. So, we know how to... I'm going to be using the brush for this episode, like so. So, we know how to divide regular numbers by each other, right? You get a number, 76, say, and divide it by, I don't know, 3048. You know, something like that. You know how that works. How do we generalize the concept of doing something like this and turn that into dividing polynomials by each other? Well, so let's have an example. I hope this example works for my purposes. We're going to say, how many times does the number 16 go into 4,144? Now, we're using this example because we want to use this example as our reference to see how we can generalize this into polynomial division. But let's talk about one very important thing about polynomial division. Something we should probably realize right now. Regular division is essentially the division of two polynomials where you just happen to know that the variable of the polynomial is x. Why? I mean, is 10. Why? Let's think about this. The number, when you're working with decimal, every digit is assigned a place value. They are 0 to 9, and then they are assigned a place value. And the place value is essentially how many tens they have been timesed by. The one in the regular ones place is just timesed by 1. But this one is times by 10, this one by 100, and so on, and this one by 1,000, and so on. So this number could be rewritten if we took all the 10s and replaced them with x's, or something like that. It could be rewritten as 4x cubed plus x squared plus... No, not 4x cubed. It would be 4x to the power of 4 plus 4x plus x cubed plus 4x squared plus 4. Oh, never mind. I was totally wrong. I was totally right the first time. Please excuse me. This is a 3, this is a 2. This is just a 1, and this is nothing. If this here, if we assume that the x value is 10, then this becomes 4,144. And then we could also be dividing this by the, well, let's just make this shorter. We could be dividing this by x plus 6, and and as far as we're concerned, these are pretty much the same equation, except that we know on the left that what we are dealing with is base 10. But on the right, this will give us an answer that will give us a polynomial answer, which then, if we substitute in 10 for x, will give us the same answer that this gives us. So far, so good. But there are some changes we need to make to how we do regular division. But this generalization is... But to start figuring out how this generalization would work, we need to do a kind of early generalization, because generalizing straight from here to here is a bit too much. But let's figure that out first, okay? Why is that so? Well, first things first, how many times does 16 go into 41? I mean, how many times does 16 go into 4? Well, it doesn't. So we say, how many times does 16 go into 41? And the answer is that it goes in 16, 32. It goes in twice, okay? So we put a 2 here, and we get rid of... We take away 32, and we end up getting the answer, a remainder of 9. Then we carry the 4. How does this work when it comes to this, okay? Already we're going to hit a problem, because we say, how many times does x plus 6 go into 4x cubed? And you're like, but that requires dividing 4x cubed by x plus 6, and I don't know how to do that. And what do you even mean anymore by how many times does it go into? Because, let's be honest, how many times does it go into is a concept that is kind of restricted to integers. Pretty much. So we're going to need to figure out basically what is the problem here. Well, the problem is that in this form we are adding a bunch of different terms together, and each term has a different x value, has a different amount of x's times by it. Whereas in here we've just got one whole term, which is one number. But remember what we learned, so we're going to need to come up with a form that is more structurally similar to this equation before we can start generalizing any further. So remember what I talked about in the video about how long division techniques work, and why when you try and divide 16 into 41, what you're really doing is figuring out how many times 1,600 goes into 4,100. Okay? So far so good, but we still need to figure out how this would work. Let's see. Imagine that all these x's were replaced with 10. You'd get 4,000 plus 100 plus 40 plus 4. Basically, expanded notation. That is what we are working with. So now we've got this form of division which uses expanded notation instead of regular old digit notation. For instance, the number we're going to be using is now 10 plus 6. That is now the number we are dividing by. Now we have to figure out how this division... Hello everyone, my name is James Ryan, and I'm here to I'm here to teach you guys how and why polynomial division works, the techniques and the technique, why it works, and how it was and one way you can derive it. Currently, we've just generalized. Well, it's not really generalized. We've just rewritten the way we do long division. Instead of working in regular old base 10 digit form, we're working in base 10 expanded notation. Okay, so 16 is now 10 plus 6, and 4,144 is now 4,000 plus 100 plus 40 plus 4. And the reason we're doing this is because now this matches up a lot more closely with this polynomial thing here. It's just that in this, we're kind of assuming that x is 10 already. So these are still more variable. This is still a much more general equation because this will give us an answer that works with any possible value of x, even decimal values. Whereas this thing is more rigid and will only give us the answer where x is 10. Technically, it'll give us but then you could just take that answer and put that in it, and just replace all the hundreds and thousands and zeros with x to that power of zeros. So I guess, in a way, this is just as general, which is very interesting. But I digress. How would we go about this? We go 10 plus 6. How many times does 10 plus 6? How many times does 16 go into 40,000? But you say, James, that's not how we did it. We said, how many times does 16 go into 4? And I say, okay, sure. But then we said, okay, it didn't go. But then we said, how many times does 16 go into 41? So, how many times does 16 go into 41? And remember, what we were doing here was we weren't just saying how many times does 10 go in, does 16 go into 41, but we were really asking how many 116s can we get into 4,100. Okay? So let's think about how we would do this. Okay? 16 goes into 41, 16, 32 goes in 2 times. But where do we write this to? Well, we should be writing it here for 200. Okay? There's a lot of ways you could figure out how to possibly go about doing this 2D, this expanded notation long division. But we need a way that matches up with our long division. And there is a problem we come across with, because already we still have the same problem as before. X plus 6 goes into... How many times does x plus 6 go into 4x cubed? I don't know. And yeah, I just don't know. Okay? That is a problem. What we do is we make sure we only take the most significant term. So x in this case, or 10 in this case. First of all, let me show you how this works out in regular old long division, except in expanded notation. Instead of considering the whole 16, we just consider the 10. And we say, how many times does 10 go into 40,000? And remember, there's no fancy going on here. I'm literally asking that. It's not how many times does 10 go into 4, or how many times does 10 go into 40, and then timesing by 100. I'm just asking straight off the bat, how many times does 10 go into 40,000? And the answer is 400 times. 10 goes into 40,000 400 times. So for here, this number here becomes 400, because we know for sure that this must go in 400 times. But wait, you say, how do you know it goes in exactly 400 times? And you're right. Because normally we also check the 6, and in this case we'd also check the 4. We check how many times does 16 go into 41, not just how many times 10 goes into 40, because 10 goes into 40 4 times, But 16 only goes into 41 twice. Reason for this is the 6. Remember? Yes. If we didn't have the 6, then it would go 10, 20, 30, 40 4 times. And the 1 wouldn't matter. It wouldn't matter that it was actually 41 we were trying to go into. But because we have the 6, it does. Because with the 6 on, it goes 16, 32, 48. Oh, 48 too much. Go back to 32. And you only get to go in twice because the 6 just adds that extra bit more each time you add 16 on, that you can't get in 4 times, you can only get in 2. And that's a problem, because since you can only get in 2 times, you get 32, you get 16, 32, but then there's a remainder of 9, and you need to take away that 9. You need to add that 9 on to the next thing, so you don't just say how many times does 16 go into 4. You say how many times does 16 go into 94, because there's still that 900 left over. Now, the thing about division is, I want to show you I want you to refer to an earlier video, which I will now record and upload separately right now. Actually, it's going to be part... No. Okay, ready? Cool. Hello everyone, my name is James Ryan. I'm back. And I am here to teach you guys how and why polynomial long division works. I just recorded, and you will hopefully have seen my video on cool division fact, because it is important for what I'm about to explain. And it doesn't matter that 10 going into 4,000 might give us 400 as an extra answer, because getting a negative, because all it will happen is we'll get a negative remainder, and that, as I've shown you, isn't the end of the world, because it's just as legit as the smallest possible positive remainder. So we say, okay, 10 goes into 40,000 400 times, but now what? Well, what normally happens is you just take the amount, we just take the number, the amount of times you went in. So for example, 16 into 41, you went 2 times, and that ended up being 32. So you took away 32. But notice that 32, but you can't really do that in this one. So how do we go about it? Notice that 32 is also 2 times, which is the amount you go in, times 16. So now we're going to say, what's 400 times 10 plus 6? Or times 16. So you times 400 by 10 and put it there, and you times 400 by 6 and put it there. The reason we include the 6 now is because now it's okay to include the 6. It's easier, and that's how we do it. Okay? It works. Because now we can lower our significance. Okay? And it's okay that if we get a negative remainder. So now we say, okay, so 400 times 10 is 4,000. So we take away 4,000. And we also, just taking away this whole thing. And 400 times 6 is 6, 12, 8, and 24. So 2,400. Yes. So 2,400. And what does this get us? Well, the 4,000s cancel out. Okay? But we still got to do this thing. What's 100 minus 2,400? Well, that is negative 2,300. Okay? Negative 2,300. Wow. And from there, now and then you'd add in the plus 40. Okay? So now you'd ask yourself, how many times does 10 go into negative 2,300? And you would say, well, 10 goes into negative 2,300 230 times. Now, of course, this is where the analogy starts to break down, because we've managed to make a number that is bigger in the wrong column. But that's okay, because this is the point where we don't need our analogy anymore. We can take our skills and what we've learned. Hopefully I've convinced you by this point that we're still essentially doing the same thing as regular old long division, except in a really roundabout sort of way. Okay? We're going to take what we've learned and apply it to these polynomials. How many times does x go into 4x cubed? X goes into 4x cubed 4x squared times. So we write 4x squared. 4x squared times x plus 6 gives us minus the following, minus 4x cubed, but also minus 4, 8, 12, 16, but also minus 16x cubed. So I might have gotten that previous question wrong with the example, but it's fine because we're doing it right now, okay? How about we go back and fix that question, eh? Yeah, sure, why not? Be right back. Just to clarify, it would actually be 400 times 6, which is 6, 12, 18, 24. Oh, never mind. Hang on, I'm stupid. Sorry, guys. Clearly, 6 times 4 is 6, 12, 18, 24. So then you would put minus 24x here. Okay? Minus 24x squared, which gets you 0 here. But then you've got a minus 23x cubed, and then plus 4x. So it's the same thing as we were doing before. Okay? How many times does x go into negative 23x squared? It goes negative 23x. And see, this is where it got weird before for when we were working with decimals, because there wasn't supposed to be that many zeros. But as you can see, when you're working with polynomials, it can't tell that 23 is a number bigger than 9. It doesn't care that there's obviously now more zeros, more decimal places than it's supposed to handle, because it's a polynomial and it doesn't really care. So it still works and it's still legitimate. Let's just finish this thing off. Negative 23x times x is equal to, we have to take the negative of everything. So negative becomes negative minus negative 23x squared, and also minus 23 times 6 is 6, 12, 18 plus 6, 12. So 120 plus 18 would be 138. So you'd say minus 138x. Okay? So this minus plus the minus minus would cancel out, but this minus minus this would get a positive. Wait, did I write 18x? It should be 138x. So this becomes 0 because it cancels out, but this 4 minus 138, so plus 4, basically you take this at 4 and you get minus, no, you get plus, it's a plus actually, it's plus 142, okay? And that there is your final answer. No, it isn't. No, it's not. It's not your final answer. Then, you've got to carry over the 4. I think. No. Here's the problem. You've got to get x, and now you carry over the 4. So, plus 4. How many times does x go into 142x? Easy. goes in 142 times. But now we've got to start taking away. We have to start taking away what is 142 times x. It's minus 142x. But we also have, what else? 142 times 6. Let's just get a quick calculator up for that. Accessories, calculator. 142 times 6 is 852. So minus then 852. And that gives us with 4 minus 852, which is 848, which is our remainder. And that is it. Turns out that this divided by this gives us the following. Gives us 4x cubed minus 23x plus 142 with a remainder of 848. And if you want to turn that remainder into what it actually represents, it would be plus the following fraction, plus 848, but then you need to divide that. And there you have it. Your final answer is the following. I'm not sure how long the video timed out. It's this plus this. Bam. There you have it. Polynomial long division. Hopefully that derivation was good enough for you. But if you have any questions or comments, please put them in the comments section below. My name is James Ryan, and I have been your host. Peace out.